It said find the acceleration at time t equals pi over 4 if s of t is 2 tangent t. All right, so to go from position to velocity, you have to take the derivative. And so you do have to know a little bit of your trig rules. The derivative of tangent is secant squared. And then to get from velocity to acceleration, I've got to take the derivative again. And this one's a little hard, or it's a little trickier, because you might want to write it like this for your notes. When we say secant squared, that really means the whole thing squared, secant times secant. So to do its derivative, you start off with the power rule, bring the power down, lower the power by 1, but then chain rule says we need to take the derivative of the inside part. And the derivative of secant is secant times tangent. Again, not a trig rule we use very often, but it's one that we will need to know. Now that we know the acceleration function, plug in 5 pi over 4. So remember, secant's just the reciprocal of cosine. So if you think of 5 pi over 4 has a cosine of negative square root of 2 over 2, that's its reciprocal. This is the same thing. And then tangent at 5 pi over 4, it's in the middle of the quadrant. Sine and cosine are the same, so that's a 1. My mistake when I did this one, this is one of the two I had trouble with. I said this was -1, so I had a unit circle mistake. These you can rationalize if you want to. This is the same thing as this. That's the same thing as that. So 4 times a negative would be positive. Square root of 2 times square root of 2 would be 2. So in the end, the answer to that guy should have been positive 8. But for that one, you need to know the derivative of tangent. Make sure you don't forget chain rule. You know it's less obvious there, and the derivative of secant would be secant tangent.